Welcome to the DNA Talks podcast, where we take on the mission of unlocking the code of your genetics. This season is all about you, upgrading your health, not just on the surface, but down to the root cause. Join us as your clinicians at the DNA company investigate your DNA and beyond. The intention of this podcast is to enhance your lifestyle by changing what is in your control. This does not substitute the medical advice given by your personal doctor, therapist, and other healthcare professionals.
Bonjour, mes amis. My name is Dr. Krista Kostroman, and I am the Chief Science Officer here at the DNA Company, and I am delighted to be with you today here on the DNA Talks with Dr. Leo Grady, who is CEO of Jona and partnering with the DNA Company to deliver the most exciting product, the DNA Gut 360 Premium. Sir, welcome. It's good to see you.
It's great to be here.
Yeah. So I wonder I'm very excited to give this talk because, as our audience knows, my life goal is to become a cyborg. And in my mind, some of what you're doing is one step closer to that, especially within the space of how do we help people with technology. So for our audience that isn't aware, would you like to give us a little bit about Jona and what exactly the DNA Gut 360 is?
Jona is an AI company that's focused on the gut microbiome. And as many of you know, the gut microbiome has emerged really as a central player in our health. In fact, almost every aspect of our health has been linked with the gut microbiome. Everything from obesity to eczema to Crohn's disease, Parkinson's disease, even cancer. Yet the challenge with the microbiome is the complexity. You have 30 trillion organisms that live in your gut. They change dynamically over time, and the science is exploding. So every single month, you have more than 2,000 studies published on the microbiome in PubMed. Nobody can analyze all of this data. No one can read 2,000 studies a month. And that makes the microbiome incredibly challenging to analyze, to understand, and then ultimately to take action on. So here's what we did at Jona. We built an AI system to read all of those studies, more than 200,000 studies in PubMed. With the gut microbiome test results, the AI matches all of the organisms in your gut results to every study ever published. And then we can say these organisms have been linked with everything from bloating and fatigue and brain fog all the way to Crohn's disease or Parkinson's or even cancer. Then the AI goes a step further and reads all of the interventional literature. How can you change your microbiome based on diet, lifestyle, supplements, medications? And we make a digital twin of your gut. And then we can actually simulate what happens if you go vegan, what happens if you go keto. And we know how those changes in your diet are going to change your microbiome. So we can make those changes digitally for you. And digitally, virtually, we can give you every dietary change, every lifestyle change, every supplement, and really figure out what's going to work best for you and your body in order to optimize your microbiome.
Yeah. So as a clinician, all sorts of excitements, and I want to break it down because I want to make sure our audience can kind of hear and understand the power and the information that is held within this. So first and foremost, you kind of spoke to the idea that research as it stands, because we are aware the biome is involved in so many aspects of health, from mental health, joint health, skin health, gut health, all the healths. There is a lot of energy, money, research going into it. And even for doctors who make the biome their core calling, their core focus, it's not possible to keep up with this literature. So you've designed something on our behalf to keep up with the literature. True?
Exactly. Yeah, exactly. Not only keep up with the literature, but to apply that literature in a way that is standardized and also takes into account the study sizes, the journal quality, to really weigh the evidence on all different sides of an issue when you do have conflicting results as well.
Yeah, yeah. And I would also offer and help me understand this a little bit. When we think of the biome, I think traditionally there was an element of reductionism. We'd get really romanced by one specific bacterial strain or one specific segment of the biome, and we'd be like, this is the cure-all, right? Which is why we see so many supplements that are just the lactobacillus or bifidobacterium, whatever it might be. We get very much romanced by that because our people minds could really only clock so much from a data perspective, right? So when I hear from an AI perspective, not only are you able to appreciate all the species equally, insofar as you're not favoring one because one is all you can compute, right? There's also this element of pattern recognition, not just looking at one species, but how communities of different species are set up. True?
Yeah, no, that's exactly right, and I think you're hitting on two really important issues here. One is that it it is very easy for us as humans to fixate on those romantic organisms that you're talking about, and yet there are more than 11,000 different organisms that have been measured in the peer-reviewed literature and linked to your health, and yet and observed in people's gut. So your ability to memorize 11,000 different organisms, to remember which ones are linked to which diseases when they're too high, it's just not possible to do all of that. And yet
Yeah.
fixating on a single organism or a set of 3 to 5 organisms just does not capture the full breadth of what's going on in the microbiome. I think the other
Yeah.
important thing that you're touching on is that it's not generally a single organism that is defining your health, right? It's a whole ecosystem shift, right? I mean, if you were to go look at the ecosystem of a national park or a forest or something like that, you wouldn't necessarily measure just the number of chipmunks or anything like that in order to understand the health of that ecosystem. You really have to look at the whole picture and see it
Yeah.
changing over time in order to understand, is this a healthy ecosystem or not?
Yeah. Yeah. And I think I think that tends to be the trajectory right now of medicine, right? Stopping to reduce. So, for example, someone comes with a concern of weight loss. We're no longer saying, well, let's just focus on food and exercise. We're also asking the bigger questions of sometimes to the biome, but also to other places of what about your stress and about your sleep? We're expanding the thought of where health sits, just like we're expanding the idea of the biome. It's no longer one strain, one species. It's the happy little community, the happy little forest that lives within. So leveraging the power of computers, we know that our computers are now reading all the literature that us mere pedestrians cannot. We know that computers are able to appreciate patterns that we just don't have eyes or brains for, right? We've eyes and brains for different things, just not the pattern recognition on this scale. And here's an interesting thing is this digital twin. And here's, I'll back this as a clinician, why this is very interesting to me. When I started my clinical career, when I started counseling people and saying, like, if there was something going on funky within the biome, there's a course of antibiotics, whatever percolated the need for a probiotic, some people would take it and they would feel great. Other people would come back and say, I have World War III happening in my gut. I strongly dislike you right now, and my gut is not happy. What is going on? And what we learned was that, tossing in a new creature, a new animal to an ecosystem isn't always going to go well. And so is this what this digital twin is trying to solve for to a certain extent? Talk to me about the digital twin, because I see that very powerfully.
If we just back up, like a lot of medicine, as you know, is very guidelines based, right? You do a randomized control trial, you get some kind of population statistic, you say people with high cholesterol, they should eat, less red meat or whatever it is, right? And that's great on a population basis. But when we talk about an individual, what's right for them? And
Mhm.
as a clinician, as a doctor, I mean, you know that you can take into account all the different vitals, their presentation, their biomarkers, and try to put those pieces together in a way that crafts an intervention that's right for them. But now with digital twin technology, we can go a step further and we can actually model the person's biology, and you can simulate what happens for that person, for that individual, under different interventions. And in the case of Jona, this is dietary interventions, lifestyle interventions, supplement interventions. But there are other digital twins out there where you can look at a whole range of pharmaceutical interventions. At one of my previous companies, HeartFlow, we were doing virtual stenting, where we could take
Mhm.
somebody's blood vessel and put in a virtual stent and recalculate blood flow through that virtually stented artery, and determine whether that stent was actually going to be effective for that individual, or whether it needed to be placed in a different place. And so
Yeah.
these tools can be extremely powerful in medicine, because they really allow the doctor to effectively do the math on how to intervene most optimally in this individual, and not to try to be able to put all that together in their heads, which is really
Mm.
impossible given the complexity of many of these interventions. And
Yeah.
so at Jona, we built this tool where there are more than 4,000 different interventions that have been shown to change your microbiome. The AI
Mhm.
has read all of those, and then we know, based on going vegan or going keto, how those things are going to change your gut microbiome. And so we can take you as you are today, and we can apply those changes digitally and make a
Yeah.
virtual vegan you, and then really see
Yeah.
whether that vegan you is more healthy, less healthy, more associated with disease or less than the current you. And by doing that systematically, and then ultimately giving you, the clinician, or even the patient directly, the power to experiment with it, that allows you
Yeah.
to dial in, using all of today's known science, really what's going to work optimally for that person.
Yeah, which is the level that we can get precision medicine now is quite powerful. I hear often, so many times, people come to me, what is the perfect diet? And from a genetic perspective, I can give guidelines, I can give trail markers, right? Insofar as your body does or does not do well with carbs or fats. But there's that layer of biome, right? There's always this comment that I have to make to people of, we're still going to be doing a bit of a science experiment, because your genes can't fully appreciate the history, the stories that your biome keeps. And so now we're bringing in this intelligence that says, here's the story of your biome, and here's what will resonate well, what will continue this story well in a favorable health.
Yeah, yeah, exactly. There was some fascinating studies. I don't know if you saw these out of Israel, maybe I don't know, 6 or 7 years ago, where they were trying to answer that question of what is the optimal
Mm.
diet, and they put
Mm.
continuous glucose monitors on people, and they
Yeah.
fed them all these different foods. And what they quickly found was that you could take two different people, feed them exactly the same food. One of them has a huge glucose spike, and the other does not.
Mhm.
And then switch the food, and maybe the second person has a glucose spike, the first person does not. And what it really illustrated was that there's no single food that is going to change your glucose consistently in the same way across all people. And then when those
Yeah.
researchers dug in and tried to understand, well, what predicts who has a glucose spike and what doesn't, they looked at genetics, they looked at blood markers, urine markers, microbiome, all of these different things. And what they found is that the number one predictor of who is going to have a glucose spike or not was their gut microbiome, really
Mm.
understanding that
Mm.
composition.
Yeah. 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 Because it eats what we eat, and then it feeds back information to the body. Yeah.
Yeah,
Yeah.
it's
Yeah.
so interconnected with your immune system, with your enteric nervous system. It's really, people talk about it like a new organ. And I think that's a
Yeah.
really effective way of thinking about it. But it's a very different kind of organ than most of the ones that we're used to dealing with.
Well, absolutely, because it's a commensal organ to a certain extent, right? It has its own mind, it has its own life, it has its own response. Yeah.
Yeah, and
So
it changes. It changes more than your liver or your heart, and it is modifiable. I mean, it's a really exciting organism, or organ, if you think about it from that standpoint, because you can almost configure it to do different things depending on what's going on in your body.
yeah, and based on health goals, right? Be that I want to fix this current plight that I am under, or I want to optimize to the end of running a marathon, or doing something superhuman. It's fascinating that we can kind of leverage it in both ways. Yeah.
100%. Yeah.
So I wonder if we can dive a little bit into your background, Leo, because you're a bit of a polymath. So I wonder if you can help draw the story, because you've mentioned some biotech, but can you draw the story of how you got to the microbiome and why it is currently the apple of your eye? What drew you into this space?
Well, my background is as an AI PhD. So that's what I did my PhD in more than 20 years ago in computer vision. And I've been working in healthcare this whole time. So I started off building AI for radiology, looking to
Mhm.
find tumors or measure hearts or whatever it is in medical images. Then I was at a cardiology company called HeartFlow, where we built a cardiovascular diagnostic test for coronary disease that used AI to really extract all of the coronary arteries and then computational fluid dynamics to calculate blood flow through those. And that was the first Medicare payment for an AI product in healthcare ever. Then I was leading a company called Page AI in New York, which was an AI company focused on pathology. So finding cancer in tissue and biopsies and surgical resections, where we had the first FDA approval in that space, looking for um, prostate cancer and needle core biopsies. Um, with all of these, I found that AI could have a very powerful effect in terms of understanding data and translating it into clinical solutions. But what got me excited about the microbiome specifically is the profound effect that the microbiome has on your health. It's much
Mhm.
broader than looking at just tissue or looking even at the heart. I mean, the gut microbiome miraculously impacts heart function, impacts atherosclerosis. I mean,
Mhm.
it's hard to believe, but the data is really clear on this through the
Mhm.
TMAO pathway. And it does, so it seemed like the opportunity with the microbiome was so much broader. And we
Mhm.
know from microbiome transplants that you can take people with chronic disease and in some cases actually even cure them with a transplant. But sometimes those transplants did nothing. Sometimes those transplants actually hurt people. And
Mhm.
what that tells me is that this is really, really powerful stuff, but we don't understand it. And I felt that
Mhm.
AI was going to be the critical technology that allowed us to consume all of that data, really understand how your microbiome is impacting your health, and then figure out what your microbiome should look like and how to get there.
Yeah.
And that's why I built Jona. I also, from a personal standpoint, my ex-wife has Crohn's disease. My other members of my family have colitis or celiac. Our kids have gut issues, and so I've seen on a personal level how challenging it can be to get a diagnosis with many of these
Yeah.
conditions. And then even when you have a diagnosis, there's a lot of trial and error to figure out what sorts of interventions would help people. These, I'm sure you're familiar with these elimination diets that, you go on this long journey of, eliminate this, eliminate that, and then, maybe you find it at the end of the day, but it seems like we ought to be able to compute the answer and get there much faster.
I think you bring up a really good point insofar as biome testing has been around for a really long time. And as a clinician, I've always had a double-edged sword relationship with it. I know it's powerful because we know how research tells us how impactful and influential and directional to health it is. That said, even if you work with the best lab and you get the best results, you get a true picture of what is in the stool, what is in the biome. My struggle has always been, well, what do we do about this? And as you know, I have a computer science background, so my getting reductionistic to one organism, I was never comfortable with. And so there was an element of, I'm not really sure how useful biome testing is to this very reason. Is it helpful if a person has a sincere overgrowth of an opportunistic bacteria? Absolutely. We know what it is. We know how to treat that. But outside of that, into the more disease space, I was a little apprehensive, and I like that you're addressing it. So, how are you going about addressing? There's clinicians like me who are skeptical of traditional biome testing, not because we don't think the biome doesn't have utility, but more because we don't. There's been this experience with the data of so what.
Yeah. Yeah, and I think I would bring it even a step further. I think there have been a lot of unscrupulous companies out there who have made wild claims, unsupported claims, some of
Say
whom
what
have
I
ended up being fraudulent, and a lot of
Mhm.
people selling probiotics or supplements as a one size fits all solution to everything,
Yeah.
and that has, in many cases, especially with more serious clinicians, created a skepticism and a level of concern about any claims that are made in the microbiome space. And so, one of the things that I set about doing very early on was
Yeah.
really building credibility around what we're doing and
Mhm.
trust. We don't sell supplements, we don't recommend probiotic brands, we don't do affiliates. We have a chief medical officer. We provide
Yeah.
evidence for everything that we say, um, and we also tell you the level of evidence, right? So if we say,
Mhm.
you know, the organisms in your gut have been linked with Crohn's disease, well, Crohn's disease has an enormous body of literature around it, right? So there's a lot of
Mhm.
evidence on that.
Yeah.
But there may be other conditions, psoriasis, ankylosing spondylitis, right, where there are studies for sure, but maybe they're just not at the same level as Crohn's disease. And so we provide a level of evidence for each of these linkages. We
Mhm.
always cite you back out to the source data. We link out to PubMed if you really want to go read all of the source material. And then on the interventional side, with the digital twin, we actually spell out the logic too.
Mhm.
So if we recommend, for example, inulin through this digital twin analysis, we tell you it's because inulin increases these organisms, decreases those organisms. We know, and for you, that change to your ecosystem is important for all of these different conditions. And we know how inulin is changing your microbiome because of these 10 studies, right? And and so all of the evidence is there, all of the logic is transparent. And that's one way in which we're really able to build trust with clinicians and doctors, and why we're seeing adoption actually in conventional medicine as well.
Mhm.
And we're spinning up our first academic medical center that's going to start using Jona clinically. We haven't announced it yet, but it's really because they feel like they can trust us.
Mm. 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 Okay. So there's an element of integrity within the business model that is at least how you're seeking to solve for the reasonable skepticism from clinicians within
100%
this
reasonable.
space and even patients, right. I've seen patients where I'm like, there's something going on, let's do a biome test, and they're like, I don't want to, what are we going to do with that, right? It's
Right.
across the board.
Right. Or they get the ick by, seeing too many slick ads and thinking, these
Hmm.
people are trying to sell me their supplements or whatnot. And generally they're right. And so that's why we've really tried to draw a hard line there and set ourselves apart in terms of building that trust and credibility.
Yeah, yeah, I love that. So talk to me a little bit about, since you're so entrenched within this space, and since it's so quickly evolving, where do you see biome interventions of health, biome analysis, however you want to take this question, where do you see it going in the next 5 years? How do you see it shifting? So we're talking to clinicians and patients alike on this forum. Where do you see it going for people?
Ultimately, I see
Yeah.
microbiome testing being more common than blood work. And that's because it tells you so much about your health, and it's
Mm,
so intervenable. And it
mm,
can be intervened by lifestyle, by diet,
mhm,
but also
mhm,
by medications. And furthermore, we know that many classes of drugs um, have their efficacy heavily impacted by your gut microbiome. And
mhm,
so, uh, you know, in immuno-oncology drugs, we know that a person's pretreatment microbiome impacts how effective those drugs can be. But for a lot of autoimmune conditions, for which we don't always know how to select the best treatment,
yeah.
there's evidence showing that your pretreatment microbiome can strongly predict which treatment is going to be most effective for you. With weight loss drugs, with GLP-1s, we see that your pretreatment microbiome impacts how those drugs are going to be uh, more effective for you or less. And even in the mental health space, SSRIs, antidepressants, we know that the person's pretreatment microbiome has a strong impact or strong predictive value on the efficacy of those drugs. And so, for all of these reasons, I believe that microbiome testing is going to be more important than blood work, because not only should it be part of any treatment plan, whether it's pharmacological or lifestyle based, but it also provides an early warning system for many conditions. I mean, what we're seeing is that
Yeah.
everything from Crohn's disease to Parkinson's to liver disease, pancreatic cancer. I mean, there's evidence that these
Yeah.
diseases show up in your microbiome long before you have a clinical presentation, and as a
Yeah.
result, um, we should be monitoring your microbiome ahead of time so that we are seeing these things before they set in when there's time to intervene. So I
Yeah.
see microbiome testing as part of your annual checkup, as well
Yeah.
as the management of any sort of chronic condition or the management of any acute condition.
Interesting, interesting, and that sets the stage well in insofar as you do it to feel out what might be coming up, but as well for what is sitting there, how to best address it.
Yeah, yeah, exactly. If you have a health issue today, it can help you understand the root cause and what to do about it. But
Yeah.
from the standpoint of prevention, for longevity, and even for athletic performance and things like this, a person's microbiome has a lot of information about what you can do to dial in your performance and to get ahead of problems before they really
Mhm.
get worse.
Yeah. Yeah. So what I'm hearing, for example, if someone was to do the DNA Gut 360 Premium, and they, for example, said, there's the test is clocking, there's a pattern of Parkinson's. That does not mean Parkinson's is presently, we should be expecting that person has Parkinson's, just that there is a pattern within the biome that is known to eventually lead to if it is not addressed.
I think a good way of thinking about it is something like high cholesterol and heart disease. If we
Okay.
measure high cholesterol, we know it's linked with heart disease. However, measuring high cholesterol doesn't mean you have heart disease,
Yeah.
and it doesn't mean you'll
Mhm.
ever develop heart disease either. At the same time, it's important to know that you have high cholesterol, and if you have ways of lowering it, you can reduce your chances of ever developing heart disease. So I think with
Mhm.
the microbiome, where we are right now is that we see these patterns that are linked with development of Parkinson's or development of Crohn's or development of whatnot.
Mhm.
It shouldn't be interpreted as a diagnosis. However, uh, it doesn't mean they're irrelevant either. And insofar, there are ways that we can change these microbial patterns uh, that can be helpful for avoiding ever developing those diseases.
I think Leo, what you're saying there is very, very powerful for not only patients, but I would also offer doctors and clinicians to hear, insofar as current state, current patterns are not fatalistic necessarily. So within the functional gene space, right? People will come to me and say, I have an ApoE4 presentation, which we know is strongly linked to um, late onset dementia, right? And people come in and say, am I going to, right? Or we might say, like, poor detox genes, or in your case, maybe a pattern that is associated with Parkinson's, a pattern that is associated with Crohn's.
Or brachygyria,
And
for example. Yeah.
yeah, what I'm saying, what you're saying, what we're both saying is that something that needs to be tended to? Absolutely. Is it fatalistic? Absolutely not. And do you have power over it? Absolutely. And I think that's going to be a really, when I think even just to the next few years of medicine, I think that's going to be one of the more transformative things. Decoupling this idea that a result means a disease, and instead a result means here's something that we truly need to work on.
Yeah, yeah, 100%. And this is, again, gets back to why I believe that microbiome testing is going to be part of everyone's annual checkup, as well
Yeah.
as really helping manage, both chronic and acute conditions,
Yeah.
because it does
Yeah.
have so much information about your state of health today, but also
Yeah.
your state of health in the future in a way that is within your hands to really take control of and make changes to.
Yeah. Yeah. Well, thank you so very much for taking the time with us today and kind of diving into something that, is murky for a lot of people for reasons of maybe they've had that bad taste in their mouth from that snake oil salesman, or separately, it's just a lot to compute. There's a lot of information there, and what on earth do you do with it? So I guess thank you for the time today, and I'm so grateful that we got the opportunity to partner and to offer this testing to people so that they can take their health, either health mystery or a proactive health journey, into their own hands and shift it in a way that is favorable to them. So, Dr. Grady, thank you so very much. I appreciate it. And hopefully we'll get you back on at some other point in time and you and I can nerd out and all things computer geeky. We'll disclaim the episode as a Nerds Nook episode, maybe.
All AI. That sounds great. Thank you so much. This was
Oh
a
my.
lot of
All right, sir. Have a lovely day and thank you so very much. And to our audience, thank you so very much for listening. If you have any questions for us, don't hesitate to reach out. That can fuel the Nerds Nook conversation. And if the DNA Gut 360 is a test you're looking to get, don't hesitate to go to our website. You can get it there, and we can be of support in its interpretation. Yeah. All right, sir. Au
Thank you.
revoir.